volumes of spheres. We've done cylinders, we've done cones. We're going to wrap it all up by talking about finding the volume of a sphere. So for the volume of a sphere, which is a ball, the moon, the planet Earth, anything round such as that sphere. To find the volume of a sphere, it is equal to the product of 4/3 pi and the cube of the radius of the sphere. So if you think about slicing the sphere in half, if you had a watermelon or a cantaloupe, you'd end up with a circle on that half. So the radius of right through the middle of that sphere. So volume equals 4/3 pi r cubed is how we find the volume of a sphere. So let's start right out of here by finding the missing measure. So if we're looking for, we have this sphere here, we've got the radius that we're looking for. They've given us a volume of 288 pi inches cubed. Still FSSU here. So we're going to start with our formula. Volume equals 4/3 pi r cubed. And again, all those formulas are on your MCAS reference sheet. You can look for those there. We're going to substitute. So 288 pi gets put in for the volume. I don't know the radius. So right off the bat, I can get rid of the pi. We're multiplying by pi on both sides. So I'm going to divide both sides by pi. That cancel those out. So those get canceled out. Those get canceled out. They're gone. Next, from here, I want to get the radius cubed by itself. So I'm going to multiply by the reciprocal of 4/3. So the reciprocal of 4/3, we've talked about this when solving equations. These 4's simplify out and these 3's simplify out. I do have to do the math over here. So 3/4 times 288 over 1. So I can grab my calculator, do 3 times 288, and then divide that by 4. I got 216. So I'm left with 216 equals the radius cubed. And we've talked about that the opposite operation of cubing something is to find the cube root. So hopefully you remember how to find your cube roots in your calculator. We've talked about that a couple of times. We talked about that in chapter 7. We talked about it in chapter 10. So hopefully you still know how to work your calculator. Find the cube root of r cubed here. And I found that 6 was the cube root of 216. So they wanted us to find the radius. So the radius of this sphere with the volume is 6 inches. Done. Remember, it's a linear measurement, that radius. Oh my goodness, my whole thing's falling apart here. All right, the last thing we're going to do here is take a look at, oh my goodness, I'm all wonky, is look at figures that are made up of 2 different shapes. So we're going to take a look at a silo. So if you're out in a farm country, they've got a silo, which is where they hold a lot of their grain until they're going to be using it. So a silo is made up of a cylinder on the bottom and then a hemisphere on the top. So again, if we think about cutting a ball or a cantaloupe in half and plunk that on top. So a hemisphere is 1/2 a sphere. So it's exactly 1/2 sphere. So if I know the volume of the whole sphere, the hemisphere is just half of that. The top of a silo is a hemisphere with a radius of 12 feet. What is the volume of the silo? So we would need to split this into 2 parts. And again, a lot of times when we're working with diagrams, it makes sense to kind of break it up into 2 pieces here. So we've got the hemisphere, which is on top, and then the silo, which is on the bottom. All right, so the first thing we're going to think about is they told us the silo has a radius of 12 feet. So from halfway to the outside of that is 12 feet. That's our radius. So what we're going to have to do is find the radius of the sphere. So notice what I've done here. I've got V with a little tiny s there. That little s is telling me I'm working with a lot of volumes. So I'm going to use the s to kind of show that this is the volume for the sphere. All right, so I'm going to find the volume of the sphere. I'm going to plug my 12 radius, my 12-foot radius into my formula. V equals 4/3 pi r cubed. I'm going to put the 12 in there. I'm going to cube that. So I got 1,728. Then I did 4/3 times 1,728. I'm kind of avoiding the pi until the last minute. I got 2,304. Then when I multiply that by pi, I got 7,234.6. So that is the volume of the whole sphere. I don't want the whole sphere. I want half of it for a hemisphere. So I'm going to find half of that. So this is V of H here for the hemisphere. Half of that 7,000 is 3,617.6 0.28 feet cubed. So there's my hemisphere. All right, so I've done part of this. I've got the volume of this top part of my silo. Now the second part of this is the cylinder. So if we think about what's going on here, my radius goes from the center of the bottom of this hemisphere here, and then it goes out. It goes out to all of the sides of that cantilever ball, in this case the silo. So from the middle of that base, it kind of goes out to all of them in all directions. So if we think about, first of all, we need the height of the cylinder, because the cylinder doesn't go all the way to the top. So this here would have a height, my hemisphere would have a height of 12 feet. So if this has a height of 12 feet, that means what's left, if the whole thing is 52, that means that from here to here is going to be 40. So my cylinder has a height of 40 feet. The whole thing is 52, the hemisphere is 12, which means the cylinder part has a height of 40 feet. Now the other thing I need to know is the radius of the base of my cylinder, which is going to be the same as the radius of the base of my hemisphere. So if this is 12, then that is, if I think about my bottom of my silo here, this is 12 also. Okay, that is 12 also. So I have to break this down and think about the different pieces, how they're stuck together. I can know a total measurement, but I'm going to have to break it up into the smaller pieces to find the little measurements that are in there. All right, so now I'm going to find the volume of my cylinder, since I know the height and I know the radius. So here's my volume for a cylinder. I'm going to plug 12 in for the radius. I'm going to plug 40 in for the height. I get 144 when I do 12 squared. 40 is my height. 144 times 40 is 5,760. When I multiply that by pi, I get 18,086.4. So I've got my hemisphere, I've got my cylinder. I'm going to have to add the hemisphere and the cylinder together. I've got 21,703.68 feet cubed. Feel free to round that to 21,704. All right. So again, we've got what we call a composite figure here. It's made up of two different shapes put together. I have to find the volume of each one separately, and then when I'm done, pull them all together.